Good morning, everybody. Welcome to today's webinar in which we're going to kind of take a little bit deeper dive into the ESTeem Horizon 900. Now, this is kind of a product that's truly revolutionized 900 megahertz and kind of taken it from the archaic days into a modern networking device. And before we get too far into the actual product itself, just to kind of let you know a little bit more of an overview of who ESTeem is we've actually been doing this since 1982. So we've got a little over 38 years of experience of designing and implementing these wireless networks. One of the key points that differentiates us is that we are the manufacturer. So we design, we manufacture these specifically for kind of the rigors of that industrial automation world. What this also allows is that we have complete ownership of all the IP, and that's both on the hardware and software side. Allows us to control the life cycle, allows us to also build in or bake in compatibility with new products going back into the older products. We are made out here in Washington State, so everything is US made. We're headquartered out here and manufactured in Washington State. We do have the industry's most complete and comprehensive portfolio of products. And so we cover the FCC license frequencies, is your 150 megahertz, the 217 to 220, 450 to 470, and then also the 4.9 gigahertz. Then we also get into kind of the bread and butter of our products these days is the license-free products. And this is the products that are available in 900 megahertz, 2.4 gigahertz, 5.8 gigahertz. To date, we've got a little over 45,000 of these across the globe in service and dating back even into the late 80s of some of the older product base. And so kind of as we take a little bit deeper dive into this is where we're involved really is in some of these heavy industries. We do a lot of water, wastewater. We do a lot of oil and gas. We do a lot of mining, a lot of material handling. Power and energy, agriculture, infrastructure, factory floor and AGV use. And so what we're seeing is kind of across the board in all these industries is we're now getting into kind of this whole digital transformation. And really kind of what you see on that graphic is that we're now kind of at that top rung. A lot of people are calling it Industry 4.0. But really what we want to look at is kind of how this has evolved as we've kind of gone from a serial-based communication scheme in which these were designed to be device to device level communication, say a PLC to a PLC. Well, everything is now basically transforming into an Ethernet base. Okay, so not only are we changing kind of that connector type and the physical structure of that data, but now all of a sudden the big goal or the big, I guess, accomplishment of this is now all of a sudden we're switching from a device level communication scheme into something that can be fully networked. Okay, so when we get into kind of the networking side of things and the connected side of it is that we really kind of face some unique challenges within this. We're trying to connect our things out there to get that data in order to get it to some analytics where we can make some intelligent decisions. But within the industrial automation world or some of these industrial type applications, we've got some unique challenges. Typically, these are very long distances. We're talking citywide or countywide coverage that we're trying to basically bring in these remote assets. We're going across waterways. We're going across roadways. We've got a lot of mobile applications. What all this really kind of comes down to is in order to really overcome these challenges, a lot of times wireless is really our best option. Now we start getting into wireless itself, there's really a couple of things that come up. Is to kind of lay some ground rules here, or at least some things that there's a lot of times we get questions like, okay, what's a good frequency or a bad frequency, or what's the best frequency to use? Well, there really is no such a thing. There's really not a good frequency or a bad frequency, but there is a right frequency and a wrong frequency for your application. And so each and every frequency has advantages, it has disadvantages. So if you kind of take this and start applying this in visible electromagnetic world that we're talking about, kind of a good way to look at this is kind of this graphic at the bottom. So when we start at the bottom of those low frequencies, they basically are able to penetrate a lot of the vegetation, go greater distances. It's just much more flexible. As we kind of climb this ladder and go into the higher frequencies, the higher we go, the more dependent or required line of sight is. When we get up into something like the 5.8 gigahertz, absolute line of sight is required. Okay, what we're going to kind of focus on today, though, is this 900 megahertz band. Okay, this kind of rides, it is basically the lowest of the unlicensed frequencies, but it is something that we can live with a little bit of obstruction, you know, some trees, some buildings. It's flexible enough to where we can apply it into, you know, some different applications and different environments. So we kind of take a deeper look into 900 megahertz itself. Really, we've got kind of two sides to the scale. We've got advantages and then boundaries we've got to consider. So the advantages really are it's license free. So you can buy this out of the box, get things up and going. There is no FCC licensing that must be done. It is the most forgiving of those line of sight obstructions. So we can live with some trees, buildings, etc. We do get better range at 900 megahertz than the higher frequencies. So kind of a good ballpark figure is about 5 to 10 miles is very typical. We can go further, but that's a kind of a good ballpark number that we're going to use as a baseline. It is a non-Wi-Fi frequency. So this can be viewed as an increased security measure because we're not having to deal with Wi-Fi devices being able to connect into this network. It also, because it's a non-Wi-Fi frequency, is it doesn't interfere with Wi-Fi networks in that same area. As we get a little bit further into this, you'll kind of see why that's important. So when we get into something that may be a building type automation, we need the speed of, say, an 802.11 network, but we want to be off of those Wi-Fi bands so we don't interfere. The other thing is these are proprietary communications. So what you have there is that you don't have that open standard or the 802.11. So again, we're increasing security that way. Now, some of the boundaries that we do have to consider with this is, as I mentioned, it is license free, but that means that you are going to be sharing that spectrum with other users in the area. So you can encounter interference, just something to consider. There are different channels that we can go to or different patterns that can be used on this so that we can basically intermingle or coexist. As I mentioned, it's also, it is a non-Wi-Fi frequency. So if your application is calling for, say, an 802.11 device to connect into the network, such as a laptop or a tablet, Wi-Fi sensors, this is not going to be a frequency that it's going to be conducive to that type of an application. Bandwidth and data rates, does it fit the application? And that's really kind of where this Horizon stands out, and we'll get into that in just a few minutes. And also it's the network architecture, those topology. And kind of what I'm talking about there is 900 megahertz itself has really kind of evolved, and this Horizon 900 really kind of led the charge to that. 900 megahertz itself is kind of this license-free 902 to 928 frequency band. It's traditionally been a very strong workhorse of the industrial automation, and it ran on frequency hopping and spread spectrum. This is one of the older generations of unlicensed equipment, and it was a technology that was developed back for the military. But what we started seeing, we started getting calls about from you, the customer, or integrators or distributors, is it started getting a little bit long in the tooth. It was kind of too slow for that digital transformation, doing things like video or some of this networking, because, you know, quite honestly, the throughput of it is limited to about 1 megabit per second. Also, it had limited topologies. It was kind of a master client or a hub and spoke type topology or an architecture that could be rolled out. A lot of that older equipment had substandard encryption, or some of it had no encryption at all, as well as, because some of the age of this, there was no updates that could be basically rolled out that could now bring that encryption level up. The other big concern with 900 is a lot of the older products, there was no backwards compatibility with the new products. So we started getting a lot of calls about this, and inquiries about it is we love the 900 megahertz, but it's just can't keep up with today's demands. So what we did is we actually came out with a Horizon 900, kind of the focus of our talk today. So when we look at this product, one of the nice things is essentially kind of think of it as we're marrying Wi-Fi technology and 900 megahertz, kind of the best of both worlds. So we continue to operate down in this FCC license frequency in the 902 to 928. Same thing that a lot of you have been using previously. Another nice part is it's the same frequency that you may have installed already that you're going to be replacing. We can use a lot of that same infrastructure. The antennas, feed lines, lightning arresters won't have to be replaced as well. Okay. Now we also start looking at where things changed radically on this is that we went to what they call OFDM modulation. It stands for orthogonal frequency divisional multiplexing. Really, what happens is now all of a sudden versus 1 megabit per second, now all of a sudden we can get up to 72 megabits per second at 900 megahertz. Okay, in addition to that speed, what this also does is this allows us to go out and deploy this in a mesh type of a system or a mesh architecture. So now we can start getting those redundant self-healing networks that are very scalable. Anybody can act as a repeater for anybody. So now we can go build that canopy out properly. All the communications are very secure and private. So this is up to AES 256 encrypted connections. Each device has multiple modes of operation. We can be what we call an AP bridge mode, which is just simply a very flat network. We can go into a masquerading mode. We can go into a routing mode. We also have station modes that allow network flexibility and scalability to be able to do this. It's all the exact same device, it's just how we configure that. It also makes it much easier for things like spare units, or if we need to add to the system, it's just the same unit, depends on how we configure it and how we deploy that. It does support basically our layer 2, which is kind of a bridge network, or your layer 3 routing connections. So basically to fit your model, is this can actually be something that's a very simple bridge, or we can go out to an individual subnet. Okay, what this also does that's very unique is now all of a sudden we can get into mobile roaming at 900 megahertz. So if you think about that, now we can have a vehicle that can actually move throughout an area and just handshake its way across, and that whole zone. We're not limited to that master client relationship. So, and we'll kind of get into that a little bit further in a little bit more detail as we kind of explore this product. So one of the things that we get often is the question of how are you pulling off this speed? So we kind of look at frequency hopping versus OFDM. Okay, we're dealing with kind of this magic world of invisible electromagnetic waves. So what we try and do is to kind of paint some pictures here. So really what we're looking at is on a typical frequency hopping spread spectrum network is we take that data and we divide it up and we send it across smaller channels. Okay, and so now each of these channels is basically rules are imposed by the FCC on this and limit that channel bandwidth to 1 megahertz wide. So really what that does is it limits the number of signals that can be sent or loaded onto each of these frequencies. The end result is when you're actually using kind of this 2-level encoding, so the maximum real data rate we can get is about 1 megabit per second. So in order to kind of keep up with today's demands, when we change this, or when we kind of release this 900 megahertz, when you look at OFDM, what you'll see here is a nice wide band that goes across, and this is the data is pushed simultaneously. Now this is the same type of modulation that you use in your Wi-Fi technology, which allows us to get those high data rates for things like video streaming or full network ability. So it's just a different type of modulation, but the big outcome of this is going to be speed. Now, when we kind of take a deeper look into this and say, okay, well, when we're talking about size of these pipes that we're getting, what does that actually look like? So again, we want to try and paint this a little bit for you to give it some good reference, is that when we look at a frequency hopping individual channel, this 1 megahertz wide channel is in real world terms, if you're actually to look at this, is about 5/6 of an inch, or 0.833 inches is how big each of those little pipes are that we're trying to send data across. Now on the same scale, looking at OFDM, these are 20 megahertz wide channels. So when we start looking at that difference, now all of a sudden on that same level or that same scale of size that's equivalent to 17 feet. So you can see now all of a sudden we've got a bigger pipeline that we can push this data through. Now why I bring this up is that is your bandwidth is directly related or controlled by the data rate, or the data rate is controlled by that bandwidth. So you can kind of see now when we get up into a 20 megahertz wide channel, we can get up to 72 megabits per second. See that little itty bitty pipe on the bottom? That's a frequency hopping channel, which is 1 megahertz wide, which we can get about 1 megabit per second. So this is really kind of the magic sauce of how we're able to pull off that increase in speed. Now, as we kind of look forward at specifically on the 900 or the Horizon 900, one of the things also that we did in order to essentially create a better mousetrap here is that we also made this into something that can be directly pole mounted. Now, it doesn't have to be, it can go into an enclosure just like you always have. But why we did this really is two things. Number one is we can get an increased range, or we can get into better performance as well as an easier installation. So it is directly pole mountable. It's a NEMA 4 rated case once everything is installed. We run PoE plus up to it, so it's just a simple Ethernet cable that runs up to that radio. Really the goal here was to eliminate those coax feed lines. Now that's done for both a cost perspective, but also a performance perspective, because that's where a lot of the losses in an RF system is going up that coax cable. Again, it's an option that you have. You can definitely mount this into an enclosure if you wish, but it is something that specifically done, to try and make a better radio. So some of the things that we're able now to do and to be able to optimize this changes to 900 megahertz is a couple things. Now all of a sudden we can take, and we've talked about this before in some of the earlier webinars, but now all of a sudden we can do industrial mesh or a mesh technology. And if you kind of recall from that, what that allows us to do is that we can now build redundant pathways. So if we lose a particular location, now all of a sudden the whole network isn't down. We simply heal and go around that, okay? What this also does is, because of the speed we've done, is we can now start talking about hybrid networking, okay? So not only are we combining different mediums, say fiber and copper and wireless into a single network, now all of a sudden we can go and start combining different frequencies in the network. So we can have a 5.8 gigahertz backhaul and then roll out 900 megahertz in order to get into maybe some of those more challenging locations in which we're going to have trees or other line of sight obstructions. But now we've got the speed in order to keep that network fully operational and fully functioning up to today's standards. One of the things that this also brings that we've talked about before is, this what we call twin bridge technology, and this is available on the Horizon 900 as well. So not only can we create these bridge links, we can actually run two independent, completely isolated networks across a single wireless device. Okay, so from a security standpoint, this actually air gaps those two networks right on the same device out there. So we could, for instance, we could really kind of separate a control network and a visualization network without having to add additional hardware. So we can reduce cost, we can reduce the complexity, and we can increase that security. Now, when we kind of look at that in what it actually is coming out, what you can kind of see here is that you've got two separate networks going to different locations. The red lines there would basically indicate where we would have, say, a control network data that's going across. Then we can have on the blue lines there, we can actually have a completely separate network that's going to be our visualization network, and those can actually go into two different ports. Again, we can do this now on 900 megahertz. Another thing that this brings that I talked about a little bit before is that we can also get into this wireless mobility or roaming. So one of the big benefits of wireless is that we're not tethered. So mobility is a very key benefit of a wireless application. And so mobile networks now provide constant data coverage for everything, say from maintenance vehicles to mining equipment, AGV use or automatic guided vehicles. And one of the differences of this is now we can actually have this installed, and those vehicles or those end devices are roaming across this network based upon RSSI, or how much signal is present. So this can actually be configured to where you can dictate, if I drop below this signal level, I'm going to roam to a better access point. Very cool stuff. And it's something that now, again, is available at 900 megahertz, not just up at those Wi-Fi bands. Again, it's all the same device. We're just now going to be configuring it into a client as opposed to as a bridging device. Okay, again, like I mentioned, is that we are operating now in this on a non-Wi-Fi channel, so we're not interfering with some of those Wi-Fi bands, or we're not being interfered with a lot of those Wi-Fi networks. So we kind of look at that. We take our same model here, say, okay, here's our mesh network. Now all of a sudden we can bring in those mobile applications and start to push the boundaries of what can be done. Now, if we kind of take this and shift a little bit differently, so maybe it's not a maintenance vehicle or a mining application, which this is a big outdoor arena. What if we need to go into a factory floor, say a lot of AGV use? Now, one of the limitations that a lot of our AGV customers are facing is that they need the speed up there for their networking and the constant, basically, connection to those. But the IT departments have said, that's great, but you can't use 2.4 gigahertz or 5.8 gigahertz. Now, all of a sudden, we can do this at 900 megahertz. And so we can actually install these and then basically blanket this entire factory floor in that 900 megahertz and have multiple access points that those AGVs can actually roam between, right? So again, it's something that is really never possible on other 900 megahertz because it just didn't have the speed or that roaming capability. So that's kind of what we want to talk about, is that, you know, one of the things to kind of consider is 900 is really kind of now a tool in your arsenal. And so there's another door, there's another option that you can look at, and that Horizon 900 is a very powerful device that I think you'd be extremely happy with. Coming up in a couple of weeks, we're actually going to have another net lab that's going to be brought to you. Some of the troubleshooting tools for wireless networking. So, you know, we've got this in now. How do we monitor this? How do we actually go look at this, and what tools are available to us? So hopefully you can join us in a couple of weeks. Eric's going to be doing a net lab, and that's on the 17th of November. If you've got any questions, feel free to either ask them here. You can email myself, which is that email address there at the top, which is tolly@esteem.com, or you can call us at the office here. So thanks again for joining us, and have a great day.